Hello everyone. Today let's solve the problem number 92, reverse linked list 2. We have already solved the reverse linked list 1, right? So it will be easier for us to solve the reverse linked list 2, right? So what the question states here, we have been given the head of the linked list here, right? So we have been given the head of the single list here. You can clearly see the element here in the example 1, it consists of the elements 1, 2, 3, 4, 5, right? So here we have been given the head of the single linked list. We have to reverse the nodes from position left to right. So from position left to right, we need to reverse. Just keep this in mind, right? Just keep this in mind. So we have been given left and right here. Before moving to this one, we have to return the updated head after the reversal. We have to return the updated head after the reversal. See, we have been given left equals 2. Left equals 2, right? So here you can clearly see, just give me a second, 1 second. So yeah, this is fine. Yeah, we have been given left this one, right this one, right? So we need to reverse these things, right? So this remains constant here. So based on the left and right, we will be reversing the list. So here, when we reverse this, what we get? So basically, we have to get 4 in this place and 2 in this place basically, and 3 remains in the middle itself, right? So this becomes 2, this becomes 4, this becomes 4, and 3 remains constant. So now after reversing this one, so output that we need to get here is 1 4 3 2 5. So that's what we got here, 1 4 3 2 5. Based on the left and right they have given, we have to reverse the linked list. That's it, the only difference between the reverse linked list 1 and 2. So here let me come to the this one 5. We have only one element, they have given left one right one, so this will be output will be 5 itself, right? The output will be 5 itself. So let's move on with the third example. We don't have the third example, only two examples they have given here. Yeah, they have given us wonderful examples just for the sake of understanding, right? So I hope the question is completely clear, man. Easy, right? So again, I'm telling here, see, we have been given left and right here. We have been given left and right. So we have to start reversing from when left equals to this one. This is 1, this is 2, this is 3, this is 4, this is 5. One based indexing. So left equals 2, we will start from this one. So basically, and right equals 4, we have been given this one, fourth index. So here we have to reverse this one. When we reverse this one, this becomes from 2 3 4, this becomes 4 3 2, right? So when we reverse this one, totally the output that we need to get here is 1 4 3 2 5. So this is what we need to return in the form of output 1 4 3 2 5. So I hope this part is clear, man. Same goes with the example 2. Now I hope the question part is completely clear. Let's quickly discuss the approach, then followed by the complexities, and then let's write the code. Let's quickly discuss the approach now. So we have the first example here, 1 2 3 4 5. Left we have been given 2, right we have been given 4. Left we have been given 2, right we have been given 4, right? So we will traverse to the nodes before left, that is node 1. So here in this case, let's call this one previous, man. Yeah, they have given here, let's call this one previous, right? So we will traverse to the node before left, nothing but here in this case before left is this one. So we will call this one as previous, we will call this one as previous, right? So we will start reversing from left to right, left to right. So next this one, we will start reversing from left to right. Here in this case, previous would be 1. So when we have only one element, in the second example we have this one, right? Previous element would be null, previous element would be null. Don't get confused here. We have only one element, so the previous element before the left we have to consider as previous, right? So this one previous will be null, previous will be null, right? So now always remember that we will keep the previous before the left, before the left pointer, so that we can reverse the element from left to right after, just after the previous pointer, just after the previous pointer. So here in this case we will this one, what do we call, we will reverse next these three, we will revert from left to right. Basically this becomes 4 3 2, this becomes 4 3 2, right? So here previous dot next should be at the point 4, previous dot next should be at the point 4, this one finally previous dot next should be at the point 4. Tail of the reverse sublist 2 should point to 5, node after right. This one is tail, this one is tail. So that's what I said in simple sentence, right? So the final list has to be 1. So here we'll keep the previous just before the left, just before the left. So next we will this one, what do we call, reverse from left to right. Then tail has to be this one, tail has to be this one, the last element, right, just next to the this one, right. If the element is present next to right, then we have to point that one to the tail, right. So I hope this is clear. Now we have reversed this one. After reversing this one, so this remains constant, 1 and 5. This is nothing but 1 and 5 remains constant. This is nothing but the tail here, right? So the output that we got here is 1, 4, 3, 2, 5, right? So the output that we got here is 1, 4, 3, 2, 5, which is equivalent to the output that they have showed for the example 1, right? I hope the approach part is completely clear. This itself, whatever I said in the approach, this itself exactly we will be articulating in the form of code, man. Exactly the same thing will articulate in the form of code. Now, as we are done with the approach part, let's quickly discuss the complexities part. So what would be the time complexity and the space complexity here? The time complexity would be here in this case, just give me a second. The time complexity would be here big of n. The time complexity would be big of n in this case. What would be the space complexity here? The space complexity would be big of 1. The time complexity would be big of n and the space complexity would be big of 1 for the code that we'll be writing in the future. This one I'm speaking of. The time complexity would be big of n and the space complexity would be big of 1 for the code that we'll be writing in the future. Right. So here on this case, I hope complexities part is completely clear. Big of n because we are making use of the single pass through the list, right? Accordingly, with the approach, we'll be just making use of the single list. I mean single pass through the list. Big of one space complexity because we are not making use of any extra space. We are going with a constant extra space that is done in place, right? That is done in place. Modifications are done in place, right? So overall space complexity would be big of 1 here, and the time complexity would be big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1. As we are completely familiar with the approach and the complexities, now let's start writing the code. So we'll be making use of the dummy node. We'll be making use of the dummy node. What we'll do here, let's create the dummy node, man. Here let's create the dummy node just to simplify the edge cases, right? When I say edge cases, like we have to reverse from head, those things we have to do, it will be very easier when we consider dummy node, right? So here in this case, this will be list node dummy. Let's assign this one to the new list node. So this is for the 0th index, right? So 0th index, right? So this is fine. After creating the dummy node, let me assign the next of the dummy to the head. Let me assign the next of the dummy to the head. This is fine. So let's move to the this one logical part, main part. Here let's move the previous to the node just before left. Let's move the previous to the node just before left. Means here this would be list node previous equals dummy. So let me assign this one to the dummy. Here let's go with a simple for loop. This will be int I equals 1, I less than left. This will be I plus plus. So within the for loop, let's assign previous to previous dot next. This is fine. So let me come out of this one entirely. Let me come out of this one entirely. Let's move on with the step 2 here. Current will point to the first node in the segment to reverse, right? So current will point to the first node in the segment to the reverse. We know this one from the approach. So let's articulate the same thing in the form of code here. This will be list node current. This points to the first node, right? So this will be previous dot next. So this one exact same thing we discussed in the approach, right? So in this case, left was 2, from 2 to 4. So previous should be just before the left pointer, means here 1 in this case for this example, right? This one I'm speaking of. The same thing we are articulating in the form of code. We are just this one we're just making use of the current pointer, which will point to the first node in the segment to the reverse, right? So let's move on with the third step. Nothing but we have to reverse the nodes between left and right. So this part I'm speaking. Now we are ready to reverse the left and right. So here we have to reverse the nodes between left and right. So just give me a second here. Yeah, here let's do one thing. Let's go with a for loop here. For int I equals 0, I less than right minus left here, So let's increment the I. So this is fine. Within the for loop, first let's save the next node. Next node means here list node next equals current dot next. This is fine. So after saving the next node, we have to skip the next means here in this case current dot next. This one, let's assign this one to the next dot next. So here next step is we have to insert the next at the beginning of the reverse part, quite obviously, right? So we are going with reversing the linked list here in this case. So this has to be next dot next equals previous dot next, and then we'll go with the previous dot next to next, or we would have considered next or future. So this is fine. We have considered next variable here, so this is fine, man. So this one has to be previous dot next. Let's assign this one to the next. Last line, nothing but the line number 17 indicates that we are updating the head of the reversed part. So we are done with reversing the nodes between left and right. So we are left with only one step. We are left with only one step, nothing but we have to return the updated list. We have to return the updated list. In our case, it has to be return dummy dot next. In our case, it has to be return dummy dot next, right? So we are done with the code. Let me format the code once and let me hit the run button. Let me format the code and let me hit the run button. So here, illegal start of expression. So where line number 17. So yeah, let me delete this equals and let me hit the run button. Hmm. So this one has to be equals here. Oh, so now you can clearly see here the sample test cases are getting passed. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.